Assalamualaikum warahmatullahi wabarakatuh. Greeting to all of us. On this occasion, I will give knowledge about Scada system instrumentation from whole generator to grid network. Before entering the discussion, allow me to introduce myself. My name is Husain Haryo from the Diploma for Study program in the 3F Electrical System at Malang State Polytechnic. Next, I will start the discussion of the first. Namely, Scada stands for Supervisory Control and Data Acquisition. Scada is a system of different hardware and software elements that come together to enable a plan for facility operator to supervise and control process. Supervisory control is a general term for a high level of overall control of many individual controls and multiple controllers. It gives the operation of supervisor an overview of the plan process and permits integration of operation between low-level controllers. Data acquisition is the process of sampling signal by measuring a physical property of the real world in the form of a signal and converting to invert analog waveform into digital numeric values so that it can be processed by computing machine. Some of the key features of Scada system are mentioned below. Supervision. Computer process the data and let personnel in charge to oversee and direct the status of the power system using the acquired data. Personnel in charge were often operator and engineer who monitor the information remotely or locally. Now, the master station is tasked to supervise most of the system. Control. Control in Scada refers to sending common messages to device to operate the instrument and control system and power system device. Conventionally, Scada relies on human manager to initiate command from an operator console on the master computer. Field personnel can also control machine using front panels. Data collection. Instead of collecting data and filling data sheet by hand, Scada automatically compile information in real time. Scada gathers data from hundreds or even thousands of sensors at a given time. It also generates backlogs for later analysis. Data communication. Scada delivers information to central hub. A communication network transports all data gathered from sensor. Earlier, system had radio or modem. Today, Scada data is transferred over Internet Protocol and Ethernet. Scada system compare of the following components. Sensor. Field instruments are an array of transmitter, monitor, and sensor. Sensors are the transducers which detect change, a physical quantity. The sensor can be analog or digital, but ultimately their purpose is the same. Sensor help its user to measuring and collect the data from various locations. The more complex a system, the more sensor we need and place. Conversion units sensors are responsible for collecting data. But we also need something to be able to receive and interpret the data. This is where the conversion units come in. Conversion units are the computerized units deployed at a specific location in the field. These are connected to sensors. They convert the information they receive into digital format, which is then sent to the centralized system to display. The two most common types of conversion units used in a Scada system are PLC and RTUs. How do we determine which unit we need? That depends on what our specification is. Programmable logic control or PLC are good for situations where we want more localized control. The programmable logic control is an industrial digital computer designed for output arrangement and multiple input. PLC is used sometimes in place of other conversion units due to their versatility, flexibility, affordability, and configuration. However, one may need good programmable skill to make the most out of it. Remote terminal unit are microprocessor controlled electronic device. Their objective is the interface to a Scada system with a sensor or whatever object or RTU is connected to. Normally, they transmit information through wireless communication. Therefore, they are considered good for function convert a broad area geographic. The above conversion unit assists as a localization point for gathering information from sensor and delivering command to control and protection relays. Communication network. SCADA system cannot exist without a properly designed communication network system. All the SCADA system aspects are really solely on the communication network. It provides a channel for a flow of data between the supervisory control, the data acquisition unit, and any controller that is connected to the system. The main function of a communication network within SCADA system is to connect the conversion unit with the SCADA master station. The data can be transmitted through various communication platforms such as internet, telephone line, power line, carrier communication, optical fiber line, cellular, radio, satellite, Wi-Fi, infrared, or other wireless protocols. Most facilities have specialized integrated network connectivity, field bus, wire or wireless due to security reasons. Master unit. Master unit are large computer console that act as the central processing unit or the entire SCADA system. The master unit offers a human-machine interface to the system and automatically regulate the managed system based on the response of input created by sensor. The master unit is considered to be the supervisory computer system because they serve as the SCADA system centralized processing units. Although the units themselves are typical large computer console, there are several other SCADA components such as software program and HMI, which could be named under this category as well. SCADA for power transmission system. Transmission line corresponding circuit model parameters are often in error as compared to value measured by the SCADA system. Without a SCADA system, this error causes the economic dispatch to be erroneous and hence lead to increased cost or incorrect billing. This error could also affect state estimator analysis, contingency analysis, short circuit analysis, distance relaying, mission stability calculation, and transmission planning in case of expansion. Therefore, SCADA integration into the transmission system is significant considered. Some main functions of SCADA in electrical system are as follows: rerouting service for station maintenance, service restoring, protective relay, voltage regulator management, load tip change control, transformer management, real-time modeling, automatic circuit insulation control, interface real-time single-line display, online operation, and maintenance logs. SCADA for power generating station, bringing an optional solution for each process to improve in power generation operation is flexible with advanced control structure. With the use of PLC and powerful bus communication link along with SCADA software and hardware in generating station. It supervises several operations include protecting, monitoring, and controlling to provide reliable energy, to minimize operational costs, and to pursue capital investment. The SCADA system is taken as seriously in generating station. The highlight function of SCADA in power plants include 1. Continuous monitoring of speed and frequency of electrical machine. 2. Geographic monitoring of coal delivery and water treatment process. 3. Electricity generation operating planning. 4. Control of active and rate power. 5. Boiler and turbine protective and their condition in case of thermal plant. 6. Monitoring of renewable energy farm and load dispatch planning. Next, load scheduling, and then historical data process of all generated parameters. SCADA for power distribution system. The power distribution system deals with the dispatch of electricity from distribution substation to the loads. Many utility companies depend on manual labor to perform the distribution tasks like interrupting the power to the load, hourly checking of key metric, fault diagnosing. SCADA implementation to power distribution only reduce the manual labor operation, and it costs but facilitates smooth process by reducing disruption. Scada system gathers the data from various electrical substations and correspondingly process it. PLC in substation continuously monitor the substation component and corresponding transmit that the central system. It is in charge of improving efficiency by maintaining a tolerable range of power factor to limit peak power demand surge, trending and arm the power operator by identification the problem spot, and then historic data and view that from remote and barely inaccessible location. SCADA facilities are needed to carry out electricity exploitation, especially real-time operation control. A SCADA system consists of the number of RTU, a master station, and a data telecommunication network between the RTU and the master station. RTU are instead at each substation or power plant to be monitored. This RTU is tasked with knowing every condition of high voltage equipment through the collect of electrical quantities, equipment status, and arm signal, which are then forwarded to the RCC through the data telecommunication network. The RTU can also receive and execute command to change the state of high voltage equipment via command signal sent from the RCC. With the SCADA system, the dispatch can get data quickly at any time or real time when needed. Besides that, SCADA can quickly warn the dispatch if there is a disturb in the system, so that disturbance can be easily and quickly resolved and normalize. The data that can be observed are the on or off condition of power transmission equipment, the condition of the SCADA system itself, and also the voltage and current condition in each part of the transmission component. Each condition has a different inductor, even if there are invalid indications. The operator will be able to find out easily. Provision control function refers to the operation of equipment remotely, such as switching circuit breakers, sending a return signal to indicate that the desired operator has been effective. For example, supervision is carried out using light indication. If the green light is on, it indicates the equipment is open, while the red light indicates that the equipment is closed, or it can display invalid condition, namely conditions that are not known whether open or closed when the RTU performs a control operation such as opening a circuit breaker. The change from red to green light on the control center indicates the operation was successfully. The master station sectionally scans the RTU by sending a short message at each RTU to see if the RTU has information that needs to be reported. If the RTU has something to report, the RTU will send a message back to the master station, and the data will be received and entered into the computer memory. If needed, the message will be printed on the printer machine in the master station and displayed on the monitor screen. The scan cycle takes a relatively short time, about 7 seconds or maximum 10 seconds. The scan cycle is a scan of all remote terminals in the system. When the master station gives a command to arrest the RTU, or RTU will receive the command, but only the RTU address matched to the command will execute it. The system is called the polling system. In practice, there is system time delay to prevent error related to the age of analog data. In addition to the scanning system, data exchange can also occur incidentally. For example, when the circuit breaker switch is closed by the substation operator, the RTO will automatically send the CB status at the substation to the master station. The dispatcher will immediately notice that the CB has been closed. In the event of a fault with the RTU, the message will be sent from the fault RTU to the master station, and a normal scan will experience a considerable delay because the master station pressed the fault message and set off an alarm so that the operator can take a necessary action as soon as possible. At other time, in most cases, the status of all equipment on the RTU can be monitored every 2 seconds. Provide information on the current state of the system to the operator in the control center. That was a little knowledge that I shared regarding Scada system instrumentation from power generator to grid network. I hope it will be used for you. The spirit to be creative in the world of electricity in order to make our electrical network system smart, modern, reliable, and economical. That's all I can share with you. If there are errors in the material presentation, I apologize. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.